On a lot of newer vehicles, they're starting to come equipped with what they call enhanced safety systems, active cruise control, blind spot monitoring, things like that. But when you do have to replace something in the system, say the vehicle does get in a collision or some other reason you need to replace a part, you do have to recode it, recalibrate it to the system. So let's walk through resetting and recalibrating the blind spot monitor radar system on this Hyundai. All right, ignition's on and the tool is hooked up, so let's power it up. Tool's going to automatically detect the VIN and ID the vehicle for me, so I'll just click on Scanner. Pull it up. There's my vehicle right there. So I'll just hit OK. And then this is going to be under the blind spot detection module. And let's do the left side first. Click on that. And then that would be under a system test. Blind spot detection calibration. So this function sets the blind spot detection radar after replacement. This calibration procedure will clear any missing calibration DTCs, which allows the radar sensors to go through the self-alignment procedure. The sensors continually self-align while the vehicle is driven. It may take up to 30 seconds and it will not allow cancellation of the process. So just so you know, once you start it, you can't stop it. So let's hit continue. Okay, so it says after ignition off, ignition on, so I have to cycle the ignition here, so we'll just do that. Okay, ignition's been cycled, so we'll hit continue. And now it says coding has been completed, so I'll just click continue there. It's going to stop communication with the vehicle. So that's one side. So let's go through and do the right side now. Go there, back to system tests, back to calibration. Can read through, will take up to 30 seconds, can't cancel it. Click continue. Once again, we have to cycle the ignition. Okay, ignition has been cycled, hit continue. Coding has been completed. Both sides are done. Let's just double check it for codes, make sure nothing happened when we were in there. Double check for codes. No codes present. Looks like this system's all set up and calibrated.
Hello everyone, welcome. Thanks for joining our diagnostic training session today. Now if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button there that says Q&A. Just click on that, type in your question, and I'll get to those at the end of the session. If you're watching on YouTube, just feel free to use the live chat function, and I'll get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last, 13 years? No, 12 years, 11 years or so. Traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so just worked in a dealership, and over time, I guess, just became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come to my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been around 30 years underhood experience for me. So our topic at hand today is ADAS 2025. Now, it's been a while since I've talked about ADAS, at least in this session. That was one of the original videos that we did for these live streams, was Intro to ADAS. And not a lot has changed since then. I guess it's just become a lot more prevalent on vehicles. It's pretty much standard. Some of these things are standard equipment on vehicles now, where they used to just be optional packages, right? But we're just going to kind of talk about a little overview of where we stand now and kind of some things that you need to be aware of, because it's really not going away. I don't want to necessarily say it's not going to get any easier, because I think in some cases it has gotten a little easier, but you still need certain equipment and you need to be properly equipped in order to do some of these vehicles. Some vehicles are easier than others. Some manufacturers, it could be a different process between different manufacturers. So we're going to talk a little bit about that. Now, if you've been to any of my classes this year at all, you'll also know that we're doing an OEM specific ADAS training throughout the year. So that'll be just throughout, kind of like an every other week thing going forward. But this is kind of our high level overview where we kind of introduce the topic, and then we'll work our way through the different makes from there. So manufacturers use mainly these four ADAS components, not so much the LiDAR, but everything else, the radar, the ultrasonic sensors, and the cameras. And they use them for, radar, they'll use them for cruise control, blind spot monitoring, that sort of thing usually. Ultrasonics pretty much just used for park assist, and then cameras used for a couple different things. Can be used for sign recognition and also recognizing other vehicles on the road, lane departure, that sort of thing. So let's talk about radar first. And radar stands for radio detection and ranging. So it works by transmitting radio waves and then calculating their return time. So it transmits a wave, and it knows what frequency that wave is. And depending on whether it comes back at a higher frequency or a lower frequency, it knows whether or not the vehicle ahead of it, or whatever the object is ahead of it, is moving away from or towards the vehicle. So that helps with not only radar cruise control, where you can lock on the car in front of you and it keeps the same distance, or for blind spot monitoring in the back, cross traffic alert, automatic braking. If you're backing up, it'll automatically put on the brakes if there's an obstacle in the way, that sort of thing. So it makes all of this stuff possible. And by networking it in the vehicle, makes all that stuff possible. So like I said, common applications you're going to see is adaptive cruise control, cross traffic alert, blind spot detection, rear collision warning, and things of that nature. Ultrasonic sensors, like I said, pretty much the only thing these are used for, at least right now, is for park assist. So it works by transmitting audio waves and then calculating return time. So radar was radar waves. These are going to be audio waves. So high frequency, higher than the human can hear. Audio waves are going to bounce off objects, and then it comes back to the sensor, and it can kind of detect where an object is and the distance of that object. So that's what's often used for park assist, like I said. Some fancier park assist systems, some automated park assist systems, they even use it for telling whether or not there is a spot that the vehicle can fit in as you drive past it. So it's still used in the park assist system. So like I said, it's not really anything outside of that, but it can be used for a little bit more advanced things than, hey, you're going to back into a trash can or a pole, right? Then we have cameras, and there can be a multitude of cameras on a vehicle. And how a camera works is it works by turning light into electronic signal. So if we think we have light coming through here, and here's the lens right there, and then that light is going to be focused onto a array right here. That's going to be a liquid crystal or something of that nature, where it's a photo sensor, and it's going to pull in that information, and then it's going to put it through some processing, and then of course it sends it out could be another ancillary processing module as well, where multiple cameras comes in and it gets stitched together for like your 360 view, that sort of thing. Often used for lane departure warning, traffic sign recognition, surround view, and parking assistance. If you think about backup cameras and also forward cameras as well, to help you with parking in that application. So as far as object recognition, it takes an awful lot of processing power on the vehicle's behalf in order to recognize what is what. There's a stop sign, there's a vehicle, there's the distance it's at. It detects multiple lines. We can see how it's got line markings there, and different vehicles being detected, and pedestrians and things like that. So it's able to process all of this pretty much in real time and understand what's going on in the space around the vehicle, right? And then we have LiDAR. LiDAR is not nearly as prevalent as the other technologies. I mean, radars and cameras especially, are pretty much omnipresent on any vehicle nowadays. But LiDAR stands for light detection and ranging. So instead of transmitting a radio wave or an audio wave, it's going to transmit light, transmits a laser. So calculates the return time once again. It can be a lot more granular than radar just because it's the laser can be a lot more precise with that. This is one off, say, an Audi, for example. It's got a spinning mirror in here, and it sends the laser out. So we got a laser diode bounces off the mirror, which is spinning around, and it sends it out at this 145-degree angle, as you can see there. Also interesting on this particular unit anyways, there is a heater grid on there as well, just so we can, just in case it frosts up, then it won't work. Right? I have noticed on my vehicle that when it's been frosty out, these last couple months over the winter, that it will say, "Hey, warning, your lane departure is not going to work because there's frost on the lens." So definitely needed if if you want those systems to work. So often used for adaptive cruise control, pedestrian detection, and emergency braking on the vehicles that it is so equipped. And like I said, it's not a ton of them out there. Maybe there's a few more than there used to be, but Audi A8 was one that I found doing the research, and that's just kind of where I found all this information. So it uses the laser in conjunction with the cameras and the radars and all that other stuff that's already on the car. Anyways, it just enhances it, right? So let's look at a little case study on a 2024 Kia Telluride. So this is top of mind right now because I just got one of these the end of last year. And it is a massive jump from what I had in my 2011 Forester. 2011 Forester's got like 5 modules on it, and none of them are ADAS. The fanciest thing's probably the ABS module on the thing, right? Or the body control module. On these, though, it's got 5 radars. It's got 4 on each, one on each corner, and one in the front for long range for the cruise control. It's got 5 cameras. It's got 1 in each mirror, 1 in the windshield, 1 in the front grille, and 1 in the tailgate. And it also has 8 ultrasonic sensors, 4 in the front bumper, 4 in the rear bumper to cover all the way around. Now, if we were going to pop in here and take a look at what's available as far as in ADAS on this vehicle with the scan tool. So we have ADAS driving, ADAS parking. So it's assist systems for driving and assist systems for parking. The corner radar, front view camera, identity authentication unit, and rear view monitor as well. So inside a couple of these, we have a variant coding for Hyundais and Kias. You may need to do this. It's optimizing functions according to options mounted on the vehicle. Carry out this function after replacing the ECU between vehicles when a warning lamp is turned on or when an error code is displayed for it. So key on, engine off. And you can go in there and you can change the country code, what country it's in if you need to. ISG, whether or not that's enabled. All these different pedestrian, and there's a lot of acronyms in ADAS, and I'm not 100% sure on what all of these are. But this option's enabled, or disabled, and then what kind of cruise control, I guess in this case, what does this have as far as what's the option for this vehicle? And then as far as parking, we got codes, data, functional tests. And then this is for surround view monitor as well. In this case, 360 view. So that's the parking functional tests. So we can see kind of what we got going on there. And then there's also a calibration for that too, for the surround view monitor. There's also a tolerance compensation for that and variant coding as well. So in order to calibrate the surround view cameras on this particular Kia, it requires some of these targets. So we got these point plates and a couple rulers, and lines need to be centered. And these are rather small, at least width-wise. They're the whole length of the car plus some in both ways. You can see that, but not nearly as big as what we might see a little bit later on a Ford. And if we want to look at, say, the front radar, codes and data, system tests in there as well. There's my data for aligning the target range, right? So we can see how far away the target would be and what the mounting height of the target is, and offset, whether or not it was aligned or not, whether it's service alignment, misalignment angles, and so on and so forth. So these are things you're going to need to know when you go and do the calibration on this radar. And it also says I need about 26 feet ahead of the vehicle, 6 feet. The beam will go 6 feet up and down, or 6.6 feet, and the reflector needs to be put in a certain spot. It needs to be level. If the reflector is too high, it's not going to work. If it's on an angle, it's not going to work. On an angle sideways, it's not going to work either. So you need to make sure the vehicle is flat and level and prepared as it would have been leaving the factory floor, which brings us to what kind of stuff do I need? How the vehicle is situated? How is that going to affect me being able to calibrate ADAS on a vehicle? So we'll talk about a couple things in here, not just wheel alignment, but it all starts with the wheel alignment. The number of required steps needed after performing an alignment only continues to grow as technology equipped on vehicles increases. Different steering systems, ADAS, etc. Vehicles with lane keep assist and collision avoidance systems need to know the direction the vehicle is traveling, as well as looking at the correct range or target to ensure proper operations. Cameras also may use inputs from a steering angle sensor, and if the steering angle sensor is not properly reset, camera may see that input as the steering wheel is turned. This can signal the vehicle to correct the steering and stay on the road, which can cause a pulling sensation to the driver, even though the vehicle is traveling in the correct orientation on the road. So if I don't have this right, I don't have the alignment right, I don't have the steering wheel right, it could feel like it's fighting me going down the road with the power steering, electronic power steering and all. OEMs go as far as to state in their service information that calibration is required after alignment, or that alignment is a preconditioning step in the calibration process. That's for ADAS calibration. It is a pre-step for that. When the vehicle is placed into motion, the front wheels will steer in the direction of the rear thrust line. The front toe changes, inducing changes in other angles. So if my thrust line is off, it's going to throw everything else off down the road. Like the camera will be throw off, the radar beam will be thrown off, all that stuff will be thrown off. The thrust angle will steer the rear of the vehicle in the direction that the rear tires are pointed, and this will cause the vehicle to rotate around its vertical axis. We call that yaw. And the ADAS object recognition devices will be misaligned on most vehicles when that happens. So we have 3 axes, of course. It's a 3D space. So yaw is kind of side to side around the center. Roll would be side to side, kind of around the center, going side to side. And then pitch is kind of your up and down axis. So the vehicle's onboard systems assume that the steering wheel is straight ahead when the vehicle is driven on a flat level road. Toe is equally divided between the 2 front wheels. There's no directional influence caused by tire or chassis, and there's no rear thrust influence causing a driver to countersteer. So it is assuming all of the calculations on the ADAS on a vehicle are assuming that everything is straight and square and everything's doing what it should do. So like I said, we got our 3 measurements, right? So we got our Z-axis, our Y-axis, and our X-axis. X is going to be the length of the vehicle from the zero line. The Y is going to be the width of the vehicle from the center line. And Z is going to be height from a predetermined datum line, whatever that happens to be, whether it's the floor or halfway up the wheels or whatever, whatever that happens to be. Once again, every manufacturer is different. You need to be concerned about yaw rate sensors too. We talked about this a little bit in our steering class a little while ago. But yaw rate sensors measure a vehicle's angular velocity about its vertical axis in degrees per second or radians per second. They use gyroscopes to monitor the slip angle, the angle between the vehicle's heading and actual movement direction. The main application of these sensors is to determine the orientation of the vehicle as it travels down the road. Yaw rate sensors play a key role in ADAS. You need to make sure that they are calibrated as well. Lateral ride height can lead to a problem. Deviation around a sensor's axis. So you can imagine if there was a radar there and it's kind of crooked to one side, it's not going to be working properly. Same thing with a camera. It's not going to be level on the horizon. Longitudinal ride height would be a difference in ride height front to rear, so we need to make sure that that is correct. And then tire size, wear differences, rotational size, and tire pressures can all affect vehicle ride height. So if my tire pressure is too low, that can affect ADAS as well. So we think about if the camera's not aligned properly, or if it's aligned to an improperly aligned up car, ADAS systems rely heavily on multiple imaging and sensor processors working together to provide an accurate position of where the vehicle is in relation to its surroundings using sensor fusion. So the braking distance of a vehicle may be affected if the camera is not calibrated, and this is just a 1 degree difference. We can see a big difference in distance as to where that is. Even a 1 degree ADAS alignment of a radar, camera, or sensor could drastically affect the ability of an automatic emergency braking system to perform its design, especially at highway speeds. Highway speeds, that distance is covered in the blink of an eye. And if we think about it, vehicles drive direction versus camera field of view. So if we're off, we're skewed a little bit, that could be a problem, right? We need to make sure the center line thrust angle is going straight down the vehicle, right? So another example of some things that we need to worry about other than alignment and other than making sure all of our sensors are calibrated properly. We need space for some operations, and we need good lighting for sure. So in this example, windshield camera calibration, 0 to 2 meters you need distance for these manufacturers, 2 to 4 meters for this, and 4 to 6 meters for Honda Acura. That's 40 feet total that I might need overall. Right, target placement could be 20 feet ahead of the vehicle. Yeah, so there we go. 2019 CRV is 15 feet long. Target placement is 20 feet from the center of the right front wheel. Required distance behind the vehicle is approximately 3 feet. Overall distance 38 feet, so almost 40 feet from front to back, necessary in order to calibrate the camera on a Honda. Now, in this example, space and lighting. Space is good. Looks like we got good distance there, but the lighting, that won't calibrate. That won't calibrate properly until you light up the rest of this panel or close that door, because the lighting needs to be even. So the contrast would not be correct on this target. So it's too bright on the bottom, not bright enough on the top. So that's a problem with space and lighting. I need to make sure that the target is illuminated entirely and enough. So in this case, we have a little app that's a light meter. It works with your phone's front-facing camera. So we see that's pretty dim. That's kind of in the medium range, and then that's nice and bright right there at a 98. So this is right out of repair information from Toyota. It says, hey, you know, it needs to be illuminated properly and fully. I remember doing one of these live streams where I calibrated a Toyota, and sure enough, one of the right side, the passenger side, wasn't lit up quite enough. It looked good to the eye, but to the camera, it just wouldn't calibrate. So we ended up going through the other two, coming back with a brighter light and doing it off camera. But, you know, happens. It can happen. So just know that it's not going to calibrate. If there's too much glare on the windshield, it won't work. If it's not, the thing's not lit up enough, it won't work. So you just need to be cognizant of these things if you're going to go and do a calibration. We also need to make sure our floor is level or flat as much as we possibly can anyways. In the concrete world, there's specifications relative to the flatness and levelness of the floor or slab, and it just gives you general numbers here. General warehouse floors, area to receive thin set tile and laboratories is where we probably want to be. Air pallets and ice rinks is even smoother, and movie and television studios are even smoother because they got to roll cameras around and stuff like that. So, you know, non-critical spaces don't need to be all that level. Also note if I got a big drain in the floor and my floor is pitched, that might cause an issue as well. The rig needs to be in the right spot as well. Having a rig like the one we have, which is the True Point rig, it can compensate for some of this, right? Mechanical rig should not be positioned on a different slab, but in the case where the rig is level and the floor is not, could be an issue. It will adjust for some inconsistencies across different slabs with our 3-dimensional imaging. That'll adjust for a difference in height and place the target and correct optical access of the camera or the radar, right? So in our case, we use our 3D imaging alignment technology to put the car in a 3D space, maps it out, and then it can compensate, you know, to a point as to where everything needs to be in order for everything to work properly. So if you're just using just a target on a stick, it's not going to compensate for that, of course. Also need to have good service information. You need to have accurate service information from the manufacturer. The first step is to research service information on what exact procedures are necessary to complete the recalibration correctly. Vehicle preconditioning is necessary as well. Four-wheel vehicle alignment must be performed before proceeding with radar alignment procedure. This is out of a Hyundai. Always perform radar alignment after removing and installing or replacing the distance sensor. And then adjust all tire pressure to specified value. Empty the vehicle. Remove any luggage, trunk room, etc. Shift the selector to P. Release the parking brake. Fully fill the fuel tank, and then check the coolant and oils are filled up as well. Clean the distance sensor area of the front bumper grill. So all of this stuff needs to be correct and proper. Needs to be basically as it was rolling off the factory assembly line, because that's how they calibrated at the factory. You also need to. This one was one that I hadn't really thought about before. But how long will the battery last while I'm recalibrating? While performing a recalibration, the total current draw from the vehicle can exceed 50 amps. So how long is it going to take to drain the battery? Depending on the battery condition, it could not take very long at all. The condition of the battery in the event that it's been sitting for possibly weeks while at the collision shop is unknown, because of course a lot of people do this either at a collision shop or sublet for collision shops. You may not, but jump packs are only to be used to jump a vehicle, so we don't want to do that. Conventional battery chargers are not intended for this either, because they tend to deliver excessive AC noise without the voltage and amperage at the correct level. Specialized battery maintainers like this EEBC Flash or the EEBC 500 that you may have seen out there before have a reprogramming feature that delivers a clean and consistent voltage and amperage, and it meets the criteria for BMW, which is the highest one right now as far as current requirements. As far as current flow requirements, not currently what the requirement is, but as far as current consumption requirements, there we go. For BMWs, which is the highest one, like I said. So we have this available. Like I said, the EBC 500 is another good choice for that as well. I'm sure there are others out there. But in our case, of course, we're going to tell you which ones we have, right? All right, let's go live on the tool and see a couple things that we can see. So I got 3 different vehicles, domestic, Asian, and European, of course. So I'm going to pull up the Kia first that we talked about earlier. We saw a few things, but we'll look in a couple different ones. So on our scan tools as well, pretty much most of them that can be currently updated anyways, have this function where we categorize. We can uncategorize if we want, but it comes categorized as default. So there's our ADAS and driver's aids down here. So we got our driving assist systems. So that was that variant coding we talked about. Parking assist systems. So that's our tolerance compensation, variant coding, our surround view monitor system calibration. Calibrate the image tolerance in this surround view monitor system with surround view control unit or the cameras, front, rear, left, or right of the vehicle are replaced. So we need to make sure everything's where it needs to be. Install that target, which we talked about before. That was the one where it had the slides down the sides, the targets. I don't know how far this is going to let me go either. Overlap the blinking crossbox of ABM monitor a vehicle, the calibration coordinates, the calibration target using plus and plus plus. So you can actually do this on the tool with the and then proper image displaying on the monitor. So let's see if it'll let me do anything. So calibration coordinates, a calibration target by using plus or plus plus. So move it plus, it's calibrated, or plus plus, we need to calibrate it again. And then we can do that, and you just move it back and you just move it around until it's calibrated and the image is correct and everything's square. So that can be done with the scan tool as long as you have the proper targets. And then this is for the surround view monitor view. Don't know what this is going to let me do. All right, so I turn that on and off. Basically, you're turning the cameras on and off. A lot of data in there too. All right. And then if we wanted to do, say, like corner radar. So there's a blind spot detection radar calibration. So assess the radar after replacement. Calibration will clear any missing calibration DTCs and allow the radar sensors to go through self-alignment procedure. They continually self-align while the vehicle is driven, may take up to 30 seconds, and will not allow you to cancel it. So I don't know if it's going to even let me go that far. Codes are successfully cleared. Vehicle must be driven to do a dynamic radar calibration as well. Takes about an hour. Vehicle speed greater than 30 miles an hour. Road conditions, straight road with guardrails, barriers, lamp posts, etc. So you do the static, and then you drive it, and then you do a dynamic. All right, and then the front radar. So those don't need a target. Front radar, I believe, does need it. Actually, that one doesn't have a test for that. All right, so let's go through the Ford now. 150. Okay, and then we have on Fords, it's unique. They have two different image processing modules. So image processing module A is responsible for the camera in the windshield, the lane assist camera. And then processing module B is for the 360 view. So if we went in there and did special functions, there's our 360 camera calibration. There's programmable module installation, which is PMI, which is image processing module B was replaced. Perform the programmable module installation using a pass-through device before continuing this procedure, or we can just do it on the scan tool like we just saw. Front camera was replaced. Do LIN new module initialization service function. So we saw that in there as well. So we can do anything we need to do when we replace this. Just with the camera calibration, however, let me back up here. Another way we can go into calibrations is if you have a tool with the service resets and relearns menu, you can go in there, and if we go down to driver aids, and I wanted to do calibrate the around view camera, I can go into my repair information as well if I have Shop Gear Mitchell. And outside view camera replace, and then remove and replace. And then there should be a camera alignment. There we go. So there's my two tubes that hold the massive roll of target. And if I come down here enough, there's my targets. So they're pretty long. They're longer than the truck in both directions for a decent amount. So over 20 feet long, probably closer to that 40 feet we were thinking about with the Honda, right? You can see it's like a big checkerboard with a bunch of dots on there, or chessboard, I guess, with a bunch of dots on there. And you just need to go through the calibration function. These are need to be a special distance away. They need to be the right distance apart as well to go through that. And it's going to give you all the different measurements in there. And then if there's any codes also, if it gives you a fault, it fails and gives you a fault, it'll tell you why. And then you can just go through there and check it. Like for example, precondition not correct, doors. Verify that all the doors in the tailgate luggage compartment lid are fully closed. And if not, that's a problem. That'll cause an issue, right? So just need to be aware of all these things. And then lastly, we'll go through this BMW. So that has, active cruise control, camera-based support system. So that's your surround view. Right, there's camera calibration for that. It's going to warn you if the camera's already been calibrated too. So it's going to say, do you want to recalibrate it again because the windshield geometry has changed or other problems? I'm going to say no because it's not going to let me do it anyways because I'm on simulator. All right, and then we have park maneuver assistance, park distance control, all-around vision camera as well. So this one has a to teach in the all-around vision camera as well, and of course that's in simulator, so that one doesn't work either. Let me just check real quick in service related. Around view camera. Okay, so camera system. Oh, I guess that one doesn't have it. There we go. After repair. So that's for the CAFIS camera. All right. Also, if you have Shopkeeper Mitchell, there is this driver assist ADAS function that's in there. That's a table. And what that will do, once it loads, is it'll give you the components on the ADAS on the vehicle, what job on that component possibly requires calibration, if I need special tools to do it, like a target, and then if I need a scan tool for it. So, for example, forward-looking radar, go in there and go to remove and replace. And then it's going to walk through the different things. Here's what the sensor looks like. It's adjustable. Here's the plug. Here's some screws. Use a screwdriver to adjust it. Here's some other things that you might need. Here's an adjustment screw. All right, here's the distance we need. Here's where the target needs to be, and so on and so forth. So it is important to have proper information from the manufacturer. So in this case, look, it's not level. It's not level. That calibration is not going to work properly if it's not level. Right, so the manufacturers tell you what they need in order to calibrate these things. So definitely make sure you have good, solid information. Make sure you're reading through all the information first before you go and try to calibrate it. Also, I am aware that there are some manufacturers that are they like to do split ears, like for Toyota and Lexus, for example. There's some split ears sometimes. And I know of one story, at least, where someone was using a different information system that was not ours. And they couldn't get the vehicle to calibrate, because they were following the calibration for whatever that system was using. And it didn't pick up on the half-year split. It was actually a newer than the one that the old system was using. So they'd never be able to get it to calibrate. Looked it up on ShopKey, and sure enough, went with the right one, and it calibrated right away. So they're blaming the scan tool, they're blaming whatever, but it was actually the information was incorrect because it was the older version of that split year is what they were trying to calibrate on. It just wouldn't work because they made a running change where that module was different, right? So you always got to make sure you have up-to-date, accurate repair information whenever you're doing that. With that, that's my time here for ADAS. Let's talk about what we're going to talk about next week. And next week is continuing on with our ADAS. We're going into our OEM-specific ADAS training for Ford. So a lot of little weird things with Ford, and we're going to dive into it, see what we need and what the capabilities are with the scan tool in order to do it. So join me again, as always, every single Tuesday, 6 and 9 Eastern. If you want to join us on YouTube, as we're doing right now, at 6 p.m. class goes live to YouTube. Go to youtube.com/Snap-on Diagnostics. You can scan this QR code and it'll bring you right there and subscribe you automatically. If you are watching on YouTube, please make sure you like and subscribe. 9 p.m. Eastern class goes to our Facebook page. So it's facebook.com/SnapOnJason, all one word, no dash in the Snap-on. Or you can join either class on Zoom. You go to snapon.com/OT to register for that. All right. Any of the other topics in this series, anywhere from intro to ADAS, like I said, that was my first one way back in 2020, all the way through our OEM series that we've started this quarter. There's actually 6 more classes after this that we've done. So we're up to 108, 109 classes that are available. So check that out. Also, do we have your email address? If we don't have your email address, you may be missing out on some good information like technical focus articles, SureTrack blogs, quick tips, new product releases. They send out my schedule periodically, so you know what classes are coming up. So if you aren't getting those, then make sure you scan that QR code there, and that will bring you to a page where you can then sign up. All right, let's get to questions. If you do have questions on Zoom, just make sure you use that Q&A button wherever it is, top or the bottom of your screen on Zoom, YouTube. Sorry, feel free to use the live chat function. Before we do get to questions, though, I want to make sure I also mention my buddy Keith, who also does free training for diagnostics, and it is tool-specific training. So Wednesdays on Zeus and Zeus Plus, Thursdays on Triton and Apollo, and it is at 7:30 p.m. Eastern Standard Time. So just make sure you log in for that, and it is, once again, free. It's about an hour and a half, hour and 45 minutes long. First hour, setup functions. Let's get your tool working the way it should. We'll talk through scanner functions and fast-track intelligent diagnostics, basically from start to finish. Then he takes a 5-minute break. Second part of the class is going to be on scope and meter functions. So guided component test, lab scope, and all that. All right. So let's get to questions. Looks like we're clear on Zoom. Let me look at Facebook. The Winton is saying hello. Welcome. Thanks for joining us as always. Nick from England joining us as well. Nick also says ADAS should be carried out when doing service maintenance. Yeah, sometimes, especially after you're doing an alignment for sure. Some things don't necessarily need to be calibrated until that. So really when there's an issue with the system, we need to calibrate it. If the vehicle's been in a wreck or we replace any of these components, replace a windshield, replace a bumper, things like that, got to be done. So, and that's that. So that is our questions. So with that, thank you very much. Oh, Greg Gentry just chimed in on YouTube. What scan tool was I just using? That was a Zeus Plus. So that's just easy enough to dial in, get it up on the screen there. But all of our tools would have the same scanner functions, right? So any of those ADAS functions they showed on the scanner would allow you to do that on any of our tools. And with that, thank you. Enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.